Okay, I think we'll go ahead and get started. Welcome everyone to Advances and Emergence Needs in Paleo Geoscience Cyber Infrastructure, a webinar series that has been organized by C4P. C4P is a collaboration in cyber infrastructure for paleo geosciences. This is an EarthCube research coordination network supported by the National Science Foundation. My name is Dina Smith, and I'm going to be the moderator today. Leslie Hsu will be running the WebEx. And today we have two speakers, two presentations. Each are going to be 20 minutes with roughly 10 minutes for questions. And we want to keep this to the hour, so I'll be pretty good about enforcing the time limits that we've given each of our speakers. If you have any questions, please send them through the WebEx chat window, and Leslie will read them out loud after the presentation. And that way you can send in a question at any time and we'll still be able to get to them. All presentations will be available, and the follow-up discussion will also be publicly archived on the EarthCube website and at the C4P YouTube channel. So our first speaker today will be Doug Bills, and if you want to go ahead and get us started.
Gil is here, so we will...
Oh, Gil is here, so we're not switching.
Sorry about that.
Okay. Well, in that sense, we'll just go ahead and get started with Gil. And Gil, if you could introduce yourself and begin your presentation, that would be great.
All right. Glad to do it.
Thanks.
I'm assuming everybody can see that okay?
Yes.
Okay. So my name is Gil Nelson, and I am with iDigBio, Integrated Digitized Bio Collections. I'm delighted to be here and have the opportunity to talk a little bit about what we do. Both as the first part, a little bit about what iDigBio is, and then a little bit about how we interface with Paleo data. So the brief outline then is to introduce iDigBio and then to talk some about the paleontological community and how it interfaces with it and with Paleo data. So NSF estimates that there may be 1.8 billion specimens in the United States, both biological and paleobiological. And there may be many, many more than that. I think it's very hard to keep count of how many specimens there really are across all domains. And in an effort to try to provide digitized data for scientists across the country, in 2011, NSF launched a $100 million 10-year Advancing Digitization of Biodiversity Collections program. And when they did that, they named the University of Florida and Florida State jointly as the hub or the national resource for the digitization of these specimens. So our goal, now we have a little over 7 years left, is to digitize about 1 billion biological and paleontological records over the rest of this project and make them available for scientists, the general public, amateurs, and everyone. So the way ADBC works is through Thematic Collections Networks, which I think was a brilliant way for the National Science Foundation to pull this off. There were so many projects being submitted to digitize collections that it became sort of bewildering to think how they would all be funded in small projects over a long period of time. So the NSF requested that these projects band together into large networks around particular research questions. The task was not to do the research for the question, but to build the data sets that made the research possible. There are at this point 10 Thematic Collections Networks. There were 4 funded the first year, 3 the second, and 3 the third. And there are some partners to existing networks, which are individual institutions who attach themselves to a network because their data sets are relevant to that TCN's work. You'll see that we have 2 TCNs at this point that are related to Paleo. The Paleo Niches project out of the University of Kansas, which was funded in the first round, and the iDigPaleo or Fossil Insect Collaborative, which was funded in this last round. There are probably going to be 3 more funded sometime between now and August. I think the decisions are almost made, but it is NSF's job and not iDigBio's job to make that decision and to announce who those recipients will be. But for the last 3 years, the decisions have been announced in July to August. So we anticipate that official announcements will be sometime this summer. So this is a map. We are in, ADB programs are in 50 states plus Guam, pretty well across the country, either a PIN or a TCN component in all of these states. So a pretty broad-ranging and wide-reaching opportunity. There are probably 200 to 250 institutions that are currently involved in TCNs. It's kind of hard to get a count on that because some of these institutions are involved in more than one, and they get counted more than one time. So iDigBio, some of its key features, and I won't go through all of these because we have a time limit, but one of the important things is that we want to emphasize the use of globally unique identifiers for collection objects. So we think that every object should have an identifier associated with it. That is not to say that every fossil in a fossil collection will have an identifier, will have a globally unique identifier attached to it, but that identifier should be available in a record that has an identifier attached to that specimen so that these globally unique identifiers that allow tracking across time. I think it's no secret that we're in a different mode for sharing data these days. Data go everywhere. Records might show up anywhere in multiple portals and in multiple systems. And if all of these can be tracked back to the same specimen with a globally unique identifier, that is what iDigBio is very interested in trying to enable. We are also very interested in persistent data sets and versioning records. So when folks send us data sets, we would like to ingest those data sets, and we would like to version the record so that if you send us another record updated from a previous record, we would like to maintain both versions of those records. We're very interested in textual specimen record data, obviously. We're also interested in all sorts of media, images, video, audio, any media that relates to the vouchered records. And I should point out that by definition, our interest through iDigBio as a result of definitions in the Advancing Digitization of Biological Collections program is that we are interested in vouchered specimens. We do not deal with observation data. We do deal with literature and field notes as they relate to individual identified specimens, but we don't deal individually with observation records. We're also working to provide virtual annotation capabilities so that those in the community can visit websites and make annotations to specimens, and those annotations then be pushed back to the owner of those data or those collection objects to determine whether or not that collections object manager or curator chooses to accept that annotation, after which it would be pushed out to every node that might contain a copy of that record. We're collaborating with the Filtered Push project out of Harvard to try to make that happen. And of course, we're interested in all sorts of data relevant to biodiversity research and to provide computational services to do biodiversity research. One of the things that we've done a lot of, one of my primary roles in iDigBio is digitization, and digitization both research and training and practice. And so we've held a tremendous number of workshops that have brought the community together to discuss and deal with digitization practices, data practices, how we get these objects available to the public in all sorts of domains. You'll notice that we have had 4 paleo-related workshops. One of our very first workshops was conducted in Gainesville by Bruce McFadden back, I'm thinking, in January of 2012. I could be off a month or two, but it was very early in the process. We had a paleo digitization workshop last September at Yale Peabody. We have a paleontological specimen imaging workshop coming up week after next in Austin, Texas. About 50 people in attendance at that workshop. And then we have a Specify Cyber4Paleo workshop in Lawrence, Kansas in May, which grew out of the workshop last September at Yale. One of the things that we've done as a result of digitization and all these workshops is develop a community-oriented digitization resources wiki, where we have stored an amazing amount of information that has come from the community. As a matter of fact, there's so much stuff now there now that it would really be fun to have enough time to actually organize it in a way that would make it even more useful. We have a number of working groups. One of those is the Paleo Digitization Working Group. Some of the folks at this meeting are in that group. And there are several phases of this, and I'll talk about one or two before I get finished today. But this is an active group that meets once a month, listens to presentations by various presenters on various topics, and also spins off subgroups, one of which is the Paleo Data Group, which I'll talk about shortly. So these working groups and workshops on this wikis are a major, I think, contribution of iDigBio. It really gives the opportunity for the community to get together and solve problems and work together. One of our working groups, which relates to C4P, is the Minimum Information for Scientific Collections Working Group, which is a group to take a look at what was the minimum information that iDigBio needed to ingest for scientifically useful records. To understand, that doesn't mean that iDigBio is interested in only ingesting a subset of data. That's not the case. We want to ingest all data that are out there that collections and collections managers and curators and systematists want us to have available to make their work possible. So the first thing we did was to develop this data model full of data model concepts, and then we carved out a group of those data model concepts that we thought we would start working on. We carved taxon out. That turned out to be extremely challenging. We're still not finished with that. We also carved out, of course, a specimen, a collection object, around which almost everything relates in our system. And then we began to look at relationships for some of our TCNs. For example, the tritrophic TCN through the American Museum looks at a group of plants, the phytophagous insects that feed on those plants, and the parasitoid insects that feed on the phytophagous insects that feed on those plants. And so we needed to begin to look at relationships, and we're trying to build those into our data model. We also started working on geology. Don't feel like we did a great job with that. Feel like we're doing a whole lot better now, and I'll tell you more about that in just a minute. So our goal really was to put the flesh on the bones of the data model, for the MIST group anyway, to put the flesh on the bones of the data model, and we really wanted to take a biologist or collection manager's perspective. As one of our PIs said early on in the process, we do not want the scientific and biological and paleobiological data to be hijacked by those of us who really like computers. We wanted mostly this to be something that is understandable and relevant to and searchable by and easily ingested by a biologist and by paleontologists. We started out with Darwin Core as our foundation, and then we augmented that with other community standards as necessary, and then we wanted to ensure that all the elements from this map to existing schemas. So we began to develop these lists of data elements and to categorize them as those that were required, highly desirable, and potentially useful. We developed several of these checklists, and I'll give you a link to those in a minute. We are now working on the geology list better. We've got a group of paleontologists that are helping us refine our geo list. We had, for example, only one field for stratigraphy. We now have 3 fields for stratigraphy, and we are looking now at how to best represent geologic context for paleo data. This is the link to the MIST Working Group and Authority Files group. You can go to this link and find listed there the spreadsheets like the ones that I just showed you, and you'll be able to look at where we are at this point. I think the one that I just showed you for geology is probably not there. It's probably in such disarray that we haven't put it out there yet, but we're continuing to add to it regularly. So the Paleo Digitization Working Group data team is Jim Beach is working with us from the University of Kansas. We hope that our information will feed into the updates, the coming updates, that Jim hopes to get out very soon that recharacterizes the way Specify deals with Paleo data. Reed Beeman representing iDigBio, Roger Burkhalter, you see the names, and then I'm representing iDigBio also. And we are working hard at this point on stratigraphy, geologic context, and figuring it out how Specify and iDigBio can both benefit from this in terms of not only storing data, but also serving and providing queries for those in the community who want to get data back out of our databases. There is Paleo data in the iDigBio portal at this point, and it's searchable. There's data, I think, from Harvard, and I think there's data from KU. More is coming. We spent about a year or a year and a half with data that were essentially trial data that were submitted by lots of folks, and then we cleaned our data store and have begun ingesting real data about, I don't know, 6 or 8 months ago, and currently have about 13 million records. So our goal then is to be able to address data that come from several databases. We want not only Specify, but Symbiota, EMU, and any custom databases out there that we can then map the data stores from those databases into iDigBio through an ingestion and feedback system. Right now, that ingestion and feedback system works pretty well for a couple of these systems. We also, because we have a lot of custom data sets, Joanna McCaffrey, who is the Biodiversity Informatics Manager for iDigBio, spends a good bit of time with email and personal communications with individuals who want to make contributions to iDigBio and helping them map and get their data mapped to our data standard so that we can ingest their data and make it available through our repository. So the MISC data schema sort of informs data coming in, data being stored, and data going out. We're working very hard now. Part of our effort with this data team is to develop good query support that allows folks that go to our portal to search data and find what they're looking for. We've got a new portal, a new interface that was released, I don't know, 6 or 8 weeks ago. And if you go to idigbio.org, you can get to that data portal very simply just by clicking on Data Portal. And then, of course, we want to provide presentations, templates and views that allow folks to use those data and to download those data into their own systems. As you can imagine, we are interested and have begun conversations briefly with PaleoDB because we're very interested in accessing the types of literature references that PaleoDB has available that we can attach to vouchered records within the iDigBio portal, and also building relationships with PaleoDB as a method for us to better serve the Paleo community. So I think that's in brief all that I have, and I'm certainly open to answering questions and listening to comments from this community. So Dina?
Dina, I just unmuted you, sorry.
Oh, that's okay. I was just thanking Gil so much for his presentation, and also thanking him for being so good about time. I didn't even have to give him the warning signal or anything. So I think we are all set to take questions, Leslie, if you want to do that.
Yes. Hopefully my audio volume is okay. Last time I had a problem, so just chat if it's not loud enough. The first question is, does iDigBio store paleo data that is not linked to a curated physical sample? For example, a radiocarbon date from adjacent sediments.
If it's not linked to a sample, then we do not store it. Everything that we do, we want to be related to a particular collection object, an identified, numbered collection object, or a cataloged collection object. So that's a very good question, though. if that tracks back to a specimen or can be related to a specimen because it was collected at the same, on the same strata that specimen was collected in, then that may well be something that we can store related to that specimen identifier. Does that make sense?
Yes, thank you. The next question is, if I have my museum's data in Specify, can I upload them to iDigBio and make them visible to the broader community?
Not only can you, but we would just be delighted, yeah, if you would do that. The iDigBio works very closely with Specify, and there are already queries built through the export manager through Specify that will allow you to export to iDigBio. Joanna McCaffrey is the person who coordinates that for iDigBio and would be the person to be in touch with. But the short answer to that question is absolutely.
Great. Okay. Next question is, how old of paleo collections can be included in your database? So I guess, what is the age of the oldest paleo collections? And please correct me over chat if I interpreted that incorrectly.
There's no limit for the age of a paleo collection object that we might store a record about. I have no idea what the oldest one is that we may have now, but certainly there is no limit. If it's a specimen record, you know, we want it.
The next question is, what's the difference between iDigBio and the virtnet database?
It's a very good question too. So virtnet is a compilation of, and I'm sure all of you probably know this, but I'm going to say it anyway. Virtnet is a compilation of 4 what used to be separate data systems that are now combined into one. It's very useful, and it's very it's vertebrate data primarily, although they do assist through their IPT with making data available through GBIF for other types of collections too, if you really twist their arm a little bit. The primary difference at this point is that they are in separate places. But I think this really brings up a very important, and we have collaboration with virtnet and are working now to figure out the best workflow to move data back and forth between virtnet and iDigBio. Now, having said that, I think this really brings up a very important part of what iDigBio is dealing with, and something that I think is extremely important in our current world of data management, and that is that these records that might be in virtnet, that might also be, and I'll take an example. I'm a PI on a project for a biological research station, and the data from that biological research station are stored in MorphBank, where I have my images stored. They're stored in virtnet, where I link to those images, and they're stored in iDigBio, where I also link to those images. Now, you might say, well, but that's the same data in 3 places. Well, it started out that way, that's true. But if I get virtual annotations from experts in the field that add data, add information, somebody knows more about the geolocation than I do, and I get a better geo reference, or I get a better determination on one of the specimens, those records could change over time, which is why that global unique identifier is so very important. So I think that's the kind of things we're struggling with now, ensuring that we all end up, even the specified data, when that specified data comes out of this collection into iDigBio, it comes with a globally unique identifier that was created by Specify. And iDigBio needs to honor that identifier because that's the identifier assigned by the lowest rank in the chain of data. And so the difference is that we're in different places. The commonality is that we may be serving some of the same records, and that those records could change over time. But if we can all link by a common unique identifier, then that will make all of this work in the long run.
Okay, next question. What were the biggest debates when determining the minimum information for scientific collections of what to include and what not to include?
Well, you know, the first conclusion was that the only thing that we could really conclude was that we needed an identifier. That everything else seemed to be somebody's minimum and not somebody else's. So our biggest challenge was to find a way that we could say not so much that this is a required minimum, but that these are highly desired properties. For example, we want some notion of taxon, be it undetermined or a taxonomic determination. We thought it was very important that we would have some notion of time, be that a date of collection or a date of living. We wanted some notion of a location, again, whether that was a paleo location or a neo location. So those were the kind of things that the collections managers and biologists said that we needed to have to ensure that these records were useful, scientifically useful. But really trying to determine that, when you say we've got to have a scientific name, and somebody says, yeah, but I have a bunch of index species that I want to put out, or an index specimens that I want to put out so folks can help us identify them. I don't have a scientific name, then, you know, we have to go with index. So the biggest challenge was not a particular, I don't think a particular element. It was the discussion of just trying to figure out what might be common to everybody, which is really not very much when we really got down to it.
Okay, we have a couple of follow-up comments here, one on the most recent question. So Kirsten Leonard says that she wants to just emphasize that the IGSN, the International Geosample Number, came to the same conclusion that the minimum is the identifier itself. But we also said that the sample type needs to be available. And then there's a follow-up comment to 2 questions ago about having the same data in different databases. Sounds like we might also need to establish protocols about which repository is the primary repository for a particular duplicated set of data. For example, if different changes were made to the same data in 2 places, which takes precedence?
That's a very good comment and a very good question. I think it's going to be extremely difficult, personally. It should just, and I'm not speaking for iDigBio, I'm speaking for Gil Nelson. I think it's going to be very difficult over the long haul to have primary repositories, if you mean aggregators. I think the generator of the data, so the collection that holds the specimen that generated the data to begin with, should be the final say about whether an annotation or a different determination is accepted or not accepted. And I think that's the model that filtered push is built on, so that the data go back, those verifications go back to the owner of that data. And I'll use the word owner loosely, but the generator of that data. And then the originator of that data can then determine whether they accept or do not accept that particular verification. If it is accepted, then that would then be pushed back out to all places where that record might exist and be a part of the filtered push network. And so it would be the naming authority or the authority of last resort would be the collection in which the specimen is held. Let me say something else about that, though. I also have this belief, and again, I'm speaking for Gil Nelson. I have this belief that we're concerned very much about resolution at this point. How do we resolve these records around these identifiers so that we know we have the same record in hand about the same, or at least we know the object about which this record is written. I think in the long run, a lot of this resolving will happen through software like Google. I mean, I think you take these search engines, and their purpose in life is to find things and to reunite things. And I think in the long run, that's what's going to eventually happen, is that we're going to, 10 years from now, 12 years from now, a lot of what now seems to be disjointed, and we wonder where the record is and who it belongs to, may be resolved by some of our more powerful search engines.
Okay, if Dina will allow me to sneak in one last question before we switch over.
Sure.
I want to say one more thing to Kirsten too, but go ahead.
Okay, here's the last question first. Is there a protocol to retire unique identifiers, or are they permanent and persistent?
Permanent, persistent, and I mean permanent. So an identifier that is a globally unique identifier, if the specimen is destroyed, the identifier is never reused because there are records for that specimen out there somewhere. And so reusing that identifier is crazy, and not particularly useful. They're definitely persistent and they don't get reused. It is okay, however, we may have more than one identifier on a single record. So a record could have 3 or 4 identifiers as long as they're all persistent and not reused. And the thing I wanted to say to Kirsten is that we have just added into the geology schema that we're looking at for iDigBio and for specify, well, maybe not specify, but certainly for iDigBio, the sample number that you're referring to, the IGSN number, as an identifier that might be something that we receive as the unique identifier for that sample.
Great. Thank you again. I'm gonna keep us moving so we can stay on schedule. So thank you so much, Gil. And again, just a reminder that this conversation and these presentations will be archived and available on YouTube. And now I would like to turn things over to our next speaker, Doug Sills, who will be talking to us about schema.org. And I will go ahead and let him introduce himself and get started.
Okay, great. Thank you very much. So my name is Doug Sills. I work for the Consortium for Ocean Leadership in Washington, D.C., and I'm involved with the Scientific Ocean Drilling Group there. My topic today, however, is going to be about microdata. And in fact, one of Gil's comments near the end, I think was a great segue to this, because really what this is about is placing machine-readable data into our web pages, into the HTML. And this is really a mechanism by which we can give hints to the search engines like Google, Bing, Yandex, Yahoo, and others on how to understand the data and to have information about what the data represents, the context of that data. So the concept, the topic is quite simple. Your standard HTML source code is extended using mechanisms for structured data. And so I'm going to take us down a little trip on this, excuse me, and talk a little bit about the motivation that I had for this. So some of the motivation that came from this in the past, both at my work at Kronos and my work at IODP, was that I did find it unfortunate that there was a lot of effort into finding and relating machine-hosted things, data hosted on machines, driven by human communication. So the need to connect information at these various locations and try and allow people to navigate between them. So one recent example that I had the fortune to work with some people that are on this talk with included the IMLGS, the geosamples.org site, and IODP's sandbox at dataoceandrilling.org, and trying to make connections between the sample IDs for Janus samples, between the Janus IDs, the IGSN IDs, and things like that. And to do that was done through a lot of communications and emails, which is traditional, right? This is how this has been done in the past to a great degree. And it made me think that, is there some mechanism that could assist us in this to kind of make this an easier process? I had some additional motivation because, like many on this talk, I've been at several of the EarthTube meetings. And if you look at one of the documents recently created by the Arizona Test Governance Group, which was the Technological Grand Challenges, a quick search through that revealed a lot of interest in things like search engines, catalogs. You know, can EarthCube provide better search engine tailored for a particular community? Is there something like a Google Kayak-like search and suggestion function? And so these were just a few that I gleaned from that document, and there are more in there. And so again, one of the things that I was interested in is how could, as a data manager, wearing my data manager, how could I enable my data to facilitate this goal, right? And so when I looked around then at the various tools that were available, I started thinking how they might apply something like this, right? We often expose our data through APIs. It tends to be one of the first things we think of. I think maybe because computer scientists enjoy writing APIs. Of course, APIs have some issues. They take focus. They can be hard to write well, require maintenance. There are patterns like OpenSearch and OpenReconcile and others that we can use to address some of these. They can require UI building on top of them sometimes for efficient use. And they can be difficult for indexers like Google and others to march through if there's not hints given or patterns followed for indexers to use on those particular APIs. Simple search simply isn't enough. It's not focused enough. PageRank, even if you domain lock, it can be difficult to find the types of information that you're after, right? Part of this is because it doesn't understand the concept, right? Is something like Neptune a particular database? Is it a god? Is it a planet? So these types of things can't be locked down in something like that. And the static or batch linking, as I alluded to earlier, can be brittle over time, right? Records change, and it's hard to propagate updates. Institutions may refactor how they're approaching their IT infrastructure and not take into account the downstream effects this may have on others that are trying to link to their data. I want to note in big red words that these are not bad or wrong options. These are tools and each have their place. I've done each of these in the past, and I wholly intend to do each of these in the future. But I began to wonder, is there something that we're missing? Is there some other tool that we could be looking at? And presentations on things like schema.org and Microdata at organizations and meetings like ESIP and AGU were in my mind and made me think about what could we do with these to address some of these goals. And so I began thinking, is HTML5 and Microdata a good tool? It has a lot going for it. It's web architectural based, so it's well known and obviously highly scalable. It's relatively easy to implement by a broad group of programmers because we have a lot of library procedures for creating these types of things in various architectures. And it has an advantage of being implementable across all these architectures. In fact, in the previous example I gave across the GeoSamples, IMLGS, and DataOcean drilling sites, those were sites that were utilizing things like PHP, D2RQ, and linked open data patterns, but they were not the same. They were not all the same. So the heterogeneous nature of those sources was not an issue when we were trying to implement this pattern. And I'll talk a little more about that pattern later. And also, because we're based on the web architecture, as we begin to exploit other aspects of that architectural content negotiation and other, we can see improvements in how we can utilize the approach. So the question then was, what could we do with this, right? If we actually took sites and placed structured data into the HTML code markup of these pages, what would we be able to achieve with something like that? Well, it turns out that Google and others have been testing how to approach things like this. So, for example, this dataset Schema Labs at appspot.com is a test that's being done by Google. And this is a dataset search engine. So it's using the schema.org dataset vocabulary, which I'll talk about in a little bit, to index a subset of sites. And so we can do searches like they suggest like weather and begin to see data sets that are marked as data sets and are associated with the term weather. And in fact, this does index some of the pages that I use in my sandbox. And so, of course, everyone should be able to rattle off a particular Janus sample ID from memory. But just by a cookbook example, I can put one in, and you can see that it found the specific resource that I have associated with that particular sample ID. And so we can go to that particular sample and get further information about that. We can begin to see what Google is doing with this if we use some of their structured data tools, right? So we can actually go in and place this particular resource into this tool and preview it. And what we see then is that Google understands how to extract the information from that page. Remember, this is not scraping. This is actually parsing, because we're using a structured approach to placing this data into this page. And further, those a little outside the scope of this talk and the time limits that we have, you can begin to see how it's understanding the data set and with the extensions that I've placed onto it, right? So I'm not utilizing just the data set vocabulary, but actually a vocabulary created for the ocean drilling program that has concepts such as leg and hole and core type and things like this, and core section and things like that. Now, Google is not, and the others are not actually honoring these vocabularies in their big search engines, right? So you can't go in and specify a particular concept with a value associated with it. For example, a sample ID associated with this in their master search engines. Yeah, there's work being done on custom search engines, domain-specific search engines, in which you could specify some of these vocabularies. Let's get back to the presentation for just a little bit. While the big search engines might be doing this, it's also possible to do this yourself on the scope of a domain, right? There are many tools and libraries for parsing the HTML structure, and there are many tools and libraries for just generating standard web crawlers. In fact, the Apache NE23 is an example of that. So that parser, which I've hosted here, but you can host yourself, allows me to put in a particular resource, a particular page, and extract then structured data from it in various formats. And in fact, if we go back and we pass in, for example, one of the sample IDs pages, you'll see that I can get that back as structured data in an RDF format. And so you can crawl sites and start to build up custom graphs, right? And in fact, this is what I did for this this initial effort, which is slightly different than what we would normally want to do with something like schema.org or Microdata. The original focus is using existing vocabularies that are on it, like data set, and I'll talk a little bit about that in a second, so that big organizations can provide the types of searching across multiple sites for information associated with particular concepts, right? But it doesn't prevent us from doing the types of things you see here, where we might mine or crawl sites within our domain. If we have 3 or 4 or 20 or 30 sites, it's not that difficult to write the crawling code and to spread that across many instances. Run that through a parser like librdf or NE3, and then build a resulting graph of our domain, right? So just as Google and Microsoft are working on their own knowledge graphs, grand knowledge graphs, of course, with myriads of things, it's feasible then on a smaller scale for a domain, such a graph could be built and passed around within a community and utilized for discovery, reconciliation of concepts, connection of concepts and data and resources. So that was what was done here then, right? We worked with the group to place the microdata into the pages, extracted by crawling and parsing, some simple code written using the Golang language, and then created a graph of the results and established links based on that graph. It should be noted that I was able to do that because I have a personal working relationship with those concepts, and so I understand how to make those relationships inside those vocabularies. That might be something that would be more difficult, require a community effort, and also has potential for error being propagated too there. So that's a major issue a person wants to be aware of. what this is a more machine-automated version of the original effort. Right? In that regard, it was a quite interesting test because what it allowed us to do then was to see the connections that existed between these sites without having to have each person extract that information, coalesce it together, try to massage the data, clean it, reconcile it against each other, generate these types of spreadsheets that then in the end can be fed back into our data models and used for that type of correlation of resources. So it provided that capacity in addition to some of the things we've seen with like the Google search. Another aspect of this is that there are different ways you can encode this microdata into the HTML DOM. And so one of them, for example, is JSON LD. So you can do content negotiation on a particular page as well. And so, quite easily, what one can see then, because no presentation is good without a curl call, a request to another sample ID and a JSON, and that responds from that, and we prettify that, and we'll see that this is JSON code that could be rapidly placed into a native collection of a parsing system. So this would be far faster. We're not delivering the entire HTML markup and extracting the structured data from it. We're simply saying, ship me JSON representation of that structured data raw, and I can quickly map that into my data collection and something like this. An interesting effort is Web Data Commons, which again is not doing this on a domain-specific level, but is doing this on their common crawl, a large corpus of sites on the internet, and they extract the RDFA, microdata, microformats, and other types of embedded structured data, and collect all this. Now, this type of information is more associated with things like calendars, resumes, recipes, menu items, hours of operation, type of commodity level things that, frankly, Google and Bing and stuff are far more interested in. At 44 terabytes compressed, you can begin to see that there's a huge amount of structured data already surfacing on the net. And so something like Web Data Commons, but focused on a domain, is a feasible outcome of something like this as well, right? Where if a domain of sites were to begin to place this type of information into the web pages representing their data sets and their information, then it could be extracted into this Data Commons tarball and distributed amongst the whole group for use in reconciliation of concepts and terms, in linking, in simple discovery, and other such related efforts. And so how would you do something like this then? So this is injecting the structured data into the system. And what you would use then is something like the schema.org Creative Works or dataset. I'll start with the Creative Works site. And what you can do then is you can actually go down and see what text might look like without markup, and then what microdata, RDFA, or JSON LD looks like in something like that. Now, inside Creative Works, there is the data catalog and data set, which are probably the two relevant vocabularies, schema.org vocabularies, that exist and are actually owned by Google and others for this type of indexing. And you can see the range of elements that are in here, from audience, person, organization, date modified, copyright, issues like that can be done in there. Now, you can extend your efforts with your own vocabularies or community vocabularies. You're not limited to those, but there's no guarantee that third-party indexers will honor those. Note that there are some gotchas, of course, in something like this. It's typical that the C data associated with a concept be visible, which can be difficult if the representation for the machine is something different than you want represented for the human. This is typically something like dates, where you might want a more human-friendly dating versus an ISO date format. The aforementioned AJAX issues and the issue with not indexing standard vocabularies. And that I'm aware of, there are no good geopatterns for doing geospatial type relationships or searches in this. One could argue that the use of zip code gazetteers or something like that might be sufficient for the oceans, but there's not a general pattern that I've seen for geospatial type information in this. Just kind of wrapping up a little bit, there are tools that do exist out there, such as the rich snippets that I showed. There's also a structured data.org linter and an IDFA resource. There are others that are in there. As mentioned, there's some testing going on, some efforts taking place at NASA to mark up data sets using this approach. Obviously, the tests that we've been doing at the Data Ocean Drilling Sandbox, and some others that are taking place, as well as the demonstrated Google site. And that's it. So I'll say thank you, and we'd be happy to take any questions that people have.
Great. Thank you so much, Doug. Appreciate that. I think we have some questions that Leslie can take over on.
Yes, thanks, Doug. The first question is, have you investigated the linked data applications that have been used mostly in the library sciences?
Yeah, so we have looked at some of the stuff that's going on in linked data in general. Of course, I think Tom's going to talk about that next week. In fact, the Data Ocean Drilling site is an open data site. And so we were mostly interested in this case, though, in focusing on the embedded microdata that could be scraped by the index sites, so like Google and Yandex and things like that.
Okay, next question. You showed a list of data type vocabulary. Is that from another source, or is it a schema.org vocabulary?
So at schema.org, there's the creative work which holds the data set and the data catalog. The other vocabularies that were in the talk, whether they came from some of these, like these elements down through here, are from a vocabulary, a spouse vocabulary that we created for the ocean drilling linked open data effort. And really in vocabularies, we would want to try to reduce as much as possible creating our own vocabularies, right? It would be better to use broad community accepted vocabularies and keep any kind of custom vocabulary creation to the most minimal that we could.
Okay, thanks. The next question or comment is that you commented that there are no geo patterns. Are you aware of schema.org/geo coordinates?
I didn't look at the geo coordinates within schema.org, but I don't know how you would use those for searching, I guess, is my thing. So for example, my thought was if you could say something like a particular resource within 100 kilometers of another resource. But I've not looked at the schema.org geo coordinates. I will look at that. But that would be, you would be encoding point coordinates. It would make the discovery and mapping, I guess, feasible, yes.
Okay, next question is, what do you think domain scientists should know about these tools, such as structured data? In your opinion, can they do specific things to discover data or make their data more discoverable?
So, I mean, schema.org within the context of data set will succeed or fail based on how much it's used, right? If Google or others begin to see a lot of resources utilizing this vocabulary, you're likely to see it incorporated either into the custom search engine or even into a broader, more general tool. Obviously, I think that they can make data more discoverable in that regards, but the real question will be just whether or not there's enough critical mass behind the effort to make it take off. The nicest thing about it, I suppose, is its low barrier to entry. It doesn't take a lot of effort to modify the HTML. You do need to be aware of the vocabularies you're using, whether they're schema.org vocabularies or whether you're incorporating your own vocabularies into it, and the issues with both of those. But if a domain, if a community of sites were to begin to systematically use it to mark up the landing pages or the scripted pages of their resources, then you might be able to see it take off not only in Google, but also for third parties building things like the data commons collection of microdata for a particular domain, or other things like that. In some ways, it's also a gateway drug, right? Utilizing this is a way to get maybe towards more semantics, linked open data, and things like that being used in the community.
All right, and we have another question. Are you familiar with GeoSparkle for geospatial queries on linked data? It was recently published by OGC.
Yes. And I think Parliament and maybe one other triple store does that. Of course, this is not linked open data, and this is not taking all the way to an actual triple store or Sparkle endpoint. This is utilizing some things like vocabulary and things like that that could be embedded into pages to improve discovery. Obviously, things like Sparkle 1.1 with federated queries, GeoSparkle for geospatial queries, those are wonderful things. But the barrier to entry to those, especially for smaller groups that don't have maybe full-time programmers, who have a lot of turnover, and they have student programmers and a lot of resources to associate with that, is relatively high, versus something like this, which has a low barrier to entry, but not quite the benefits of something like, a Sparkle 1.1 or GeoSparkle type interface would have. Those are wonderful tools.
Okay, thanks. There are no further questions at this time.
Oh, okay. Well, I want to thank both of our presenters today for their really interesting presentations and great responses to questions. Again, this webinar will be available later, both at the EarthCube website and at the C4P YouTube channel, Cyber4Paleo. For future webinars, please be sure to check the C4P webinar schedule at earthcube.org. And thank you, everyone, for attending.